Let's talk about a couple of words you use all the time: work and energy. But here's the thing: what you think they mean and what science says they mean, well, they're probably two totally different things. So let's get into what it really means to get something done.
So let me ask you this. Right now, as you're sitting there watching this, are you working? I mean, you're using your brain, you're concentrating, but in the world of physics, the answer might actually be a big, fat no.
And here's that disconnect in a nutshell. On one side, you've got what we all call hard work, cramming for an exam, thinking through a tough problem, or even pushing on a wall with all your might. But then physics comes along and says, nope, this over here is work. Lifting something, climbing, pulling. The key isn't how much you sweat, it's whether something actually moves.
You heard me right. All that mental strain, all that physical effort against an object that refuses to budge, according to the laws of physics, you've accomplished exactly zero work on that object. How is that even possible?
Okay, so let's dive into our first big idea here. Figuring out how all that effort we call hard work might not be work at all. Let's get into the physics.
In our everyday language, work is all about the effort, right? Think of Kamali studying for her exams. We'd totally say she's working hard. Or imagine pushing a giant rock with everything you've got, or even just standing still, holding a super heavy box. You're getting tired, you're burning energy. But in physics, something really crucial is missing.
So if all that huffing and puffing isn't work, then what in the world is? Well, the answer is in the very strict scientific definition that kind of changes everything.
And here they are, the two golden rules. For work to happen, first you need a force, a push or a pull. But, and this is the absolute game changer, the object has to actually move. It needs to be displaced. If either one of those things doesn't happen, no work gets done. It's really that simple.
It all boils down to this simple formula. Work equals force times displacement. So, you could be pushing that rock with an incredible amount of force, but if its displacement, that S, is zero, well, anything times zero is zero. No movement, no work. End of story. And we actually measure this work in a unit called the joule, named after the physicist James Prescott Joule. Just to give you a feel for it, 1 joule is the work you do when you use 1 Newton of force to move something 1 meter.
Okay, so if work is the action of moving something, what's the fuel that makes that action possible? Well, that brings us to its inseparable partner, energy. And here's the core link right here. Energy is simply the capacity to do work. If something has energy, it has the ability to make a change, to apply a force and cause that displacement. It's a transfer, really. The thing doing the work gives up some energy, and the thing being worked on gains it.
And energy isn't just one thing. It's all around us in like a million different flavors. You've got the mechanical energy of a car, the heat from a fire, the chemical energy in your lunch, electrical energy, even light energy. It's the whole shebang. For what we're talking about today, though, let's just zoom in on the 2 main types of mechanical energy that are tied directly to the idea of work. That's kinetic and potential energy.
First up is potential energy. Just think of this as stored energy. It's energy that's ready and waiting to be let loose. When you do work on an object, like pulling back this bowstring, you're literally transferring your energy to the bow. That energy is now stored right there in the bent wood, just waiting to do work on an arrow. It's the energy of position.
So when you lift a book off the ground, the work you do against gravity doesn't make the book go faster, right? Instead, that energy is stored in the book as potential energy, just because of its new, higher position. We can even calculate it. Gravitational potential energy is just the object's mass times g, which is the acceleration of gravity, times its height. The higher you lift it, the more potential energy you've got stored up.
Now, what happens when you let go of that book or when that bowstring is released? All that stored potential energy instantly converts into the energy of motion. And that is kinetic energy. The formula for this one is 1/2 times mass times velocity squared. And pay attention to that squared part. It means that speed plays a massive role here. So we have work, which is a transfer of energy. And we have energy that can be stored as potential or expressed as the motion of kinetic energy. But how does it all connect? Well, there's one beautiful universal law that ties this whole thing together.
And this is it, the law of conservation of energy. It's one of the most fundamental rules in all of physics. It means the total amount of energy in a closed system is always constant. You can't make new energy from scratch, and you can't just delete it. You can only change what it looks like. Let's watch this happen. Imagine an object held high in the air. At this starting point, before it's dropped, all of its energy is potential energy. It's not moving, so its kinetic energy is at zero.
Now, you let it go. As it falls, its height goes down, so its potential energy drops. But it's picking up speed, so its kinetic energy is climbing. Halfway down, the energy is perfectly split, 50-50.
And then, in that split second right before it hits the ground, its height is basically zero. So all that potential energy it started with has been completely converted into kinetic energy. The total energy never changed, it just swapped outfits.
So, to bring it all home, here's the bottom line. Work is the action. It's the process of using energy to create motion. And energy? That's the fundamental currency you need to do that work. They're just two sides of the very same coin.
So I'll leave you with this thought. Now that you know the rules, just look around you. From the sunlight pouring through the window to the chemical energy in your body powering these thoughts, where do you see the biggest work being done? Where's the energy coming from? It's kind of amazing when you start to see it everywhere. Thanks for tuning in.